some reactions. Okay, so there are many, many possible ways in which we can connect atoms to carbon, all right? Now, carbon is very versatile. It can have 4 bonds. We can have single, double, and triple bonds. We've learned in great detail about alkanes, alkenes, and alkynes. And just, and you might think that they can be quite complicated, but by the addition of things like nitrogen and oxygen and sulfur, we can create many, many, many other compounds. And each of these compounds has their own set of physical and chemical properties, and each of them can be used for various, various functions. Their properties allow them to have certain uses, all right? So it would take, well, who's kidding who? I took, I think, 2 organic chemistry courses. Here was the last book that I took. And you can learn pages upon pages upon pages, different ways in which they react and how you put certain atoms in different places if you want to build a molecule, all these different ways in which to build these things. And you can have a career in organic chemistry. Types of careers that you could have. You could work for the petrochemical industry in refining, oil and creating oil-based products. You can work in the plastics industry, making different types of polymers and plastics and things like that. You can work in the pharmaceutical industry where you're creating drugs and various compounds that react with cells and various parts of the cells in certain ways. So this topic can go on and on and on. So this is truly just an introduction that we're giving you here. So what I want to talk about today is very briefly about the other functional groups, all right? And so you can write that down. Very briefly about the other functional groups. And a little bit about their properties. And then I'm going to give you one example of a synthesis reaction, how we can make a particular type of these functional groups out of other chemicals. So again, a little taste of how really complex this is. To be honest, I didn't like organic chemistry in university. There were too many variations of the way things could be done that it became memorization. Biology uses a lot of organic chemistry. And again, if you've taken a biology course, you probably realize that you memorize a lot of information about something and then you spit it back out. I've always been better at learning a rule or a law like in physics class and then applying it to many different questions. I don't mind doing that. But the memorization is not my strength, and it didn't appeal to me. So again, there seems to be a fair bit of memorization. Now, in terms of our test, that sheet that I gave you, if you could please only write in the boxes, I will let you use that sheet on the test. All right, that sheet that I gave you, you see what I'm talking about? Instead of having to memorize all these functional groups, because I'm going to go over what? 1, 2, 3, 4, 5, 6, 7, 8 different functional groups. So I'm going to let you use that kind of as a key, right? Kind of to help you recognize those functional groups. Because I'm going to go through it in 20 minutes, right? To sit and memorize that whole page doesn't necessarily do you any good. So please keep that page nice and neat when you take the note today. Hopefully I don't make too many mistakes. You don't have to do too much erasing. You might want to use pencil in case I make a mistake. Because I kind of created this lesson for the purpose of going through some extra functional groups and then doing the lab. So again, I'm going to let you use that page on the test. Keep it nice and neat. So there are many other organic compounds that contain atoms other than carbon and hydrogen. The presence and position of these atoms results in different functional groups. Examples of other atoms are oxygen, nitrogen, and sulfur. So we've seen that. So let me give you an example of one here. And we're going to just talk about functional groups that contain oxygen. Oxygen can bond in a structure in many different ways. So a classic example of an oxygen functional group is an alcohol group. It's technically called a hydroxy group, but don't worry about that. And alcohols have an O in between an H and a carbon. Now I'm introducing you to a notation here with a letter R. When we write a letter R in a representation of an organic chemical, it simply means a group of carbons. It's technically called an alkyl group. Again, don't worry about the term alkyl. It's just a term that comes from various things, but it represents some alkane or alkene or alkyne connected to that. So here I've got ROH, and here I've got the simplest form of alcohol. It's just got a CH3, and in the place of the fourth H is an O bonded to an H. All right? This particular alcohol is actually called methanol. So instead of methane, we put all on the end of it. Actually, I'll write that down. So this is called methan, just like methane or methene, but you can't have a methene, but methanol. We end it with all. All right? In the grade 12 university course, we would take a couple of days to learn how to name complex alcohols. We'd learn about all the reactions that alcohols can undergo, et cetera, et cetera. Okay? So what I want to do now is I want to go to that grid and I want to summarize the functional groups that contain oxygen, all the possible ways in which oxygen can bond in and amongst the carbon atoms. We're good to go? I'm not sure where everybody is at. Here we go. So here we've got the chemical family name, the general structural formula, and then we've got the naming suffix and the example, and then boiling point, and then yours, you'll notice it says use for the group. And that's where I want you guys to do a little, maybe a little search to find some uses for that, all right? Now, the chemical name, the first one I'm going to do is the alcohol. Alcohol, all right? And the alcohol, the general structural formula, is going to be R with an OH. So you need to see an OH on the side of it. The naming suffix is, and this dash that I'm going to put here, well, I'll just write it then just as all. I'll just put all. I was going to put a dash all, like methanol, but just all. We'll write all. An example, CH3, CH2, OH. And what do you think the name of that one would be? I've got my chart still over there. I didn't bring it to front and center. But our chart still counts. What do you think that's going to be called? Yep. Ethanol. Ethanol. Ethanol is the alcohol that's found in beverage alcohol. There are many, many, many other types of alcohols that can exist. You wouldn't want to ingest those others because they don't do good things to the body. Some people would argue that ethanol doesn't do good things to the body, right? But that's the same as in beverage alcohol. Boiling point, what state is it in at room temperature? All I'm going to say is that it has a low boiling point. And at room temperature, they can be gas. Well, they're typically liquids. They're typically liquids. Oops. Liquid. So they're like water in terms of their properties. They boil anywhere between, say, 50 degrees Celsius and maybe 120 degrees Celsius, where water boils at 100. So very much like water. Now, the use, I was going to have you guys maybe come up with a use as we do it, but maybe I'll leave that for you guys to finish off later on. And all you'd have to do is, uses for alcohols type thing. Just do a Google search and see what you can find. Okay? And yeah, you might find beverage alcohol. Who's kidding? Okay, so let's move on to the next one. So next, instead of putting the O by an H, we're going to put the O in between two carbons. So we got carbons on opposite sides, as if the oxygen is holding hands, the two carbon groups. And this is called an ether. All right? And in terms of the suffix, there isn't really one that is used here. The naming system for ethers is a little complex. I'll give you the name of the example that I'm going to write down, but it's a tricky naming system, and I can't just put a simple suffix for it. So I can have CH3O CH3. I'm hoping you're finding there's enough room in there. I don't know. We're okay? This is called methoxymethane. I apologize for going into the other line. I'm not going to make you name these things, but it is nice to know what the name is. Notice how this is like a meth, one carbon, and an oxygen. Hence it gets the name methoxy. Notice how it's stuck to, again, a single carbon, like a methane. So we've got a methoxy on a methane, okay? Now its boiling point is, again, very low, and I want to check my chart and make sure I don't screw it up. It is very low, all right? And it tends to be gases at room temperature. So they're not even in the liquid form at room temperature. An example of an ether, I remember when I was young and it was cold out and we'd have to start a tractor to do whatever, say during the winter. If a tractor didn't start, sometimes my dad would use a can of ether, and call it ether, and spray it and it would vaporize very quickly. You put it in the intake of the engine and it starts an engine up. Sometimes in the past, so like I'm talking maybe a couple hundred years ago or 100 years ago, when someone was to be put out for a surgery before they had modern anesthetics, they would put ether right on a rag and it would evaporate very quickly, and you'd hold that over the face and eventually the patient would be knocked unconscious. So ether, right, for doing that type of thing. Anyway, those are some examples just to let you know, just to give you a reference to it. So notice what we've done here. Here we've got the oxygen between a carbon and a hydrogen, kind of like it's on the end of the chain. And here we've got a oxygen between two carbons, as if we've moved the oxygen into the middle. See how we've done that? We just kind of moved it over. Okay. Now we're going to create a double bond. So we're going to have our carbon and then a double bond with the oxygen. That's going to leave one extra bond free. And for this one, that extra bond is going to have an H on it. Again, just like we count our bonds, each carbon's got to have 4 things attached to it. 3 bonds to the carbon, we need an H. This is called an aldehyde. And I'm going to go back and check my spelling so I don't screw it up. aldehyde. And I need an E on the end of it. An aldehyde. Okay? And this gets, I better check it to make sure. This gets a suffix of al. Al. And I'm going to draw a very simple aldehyde with the H on the end. And I'm not even going to put another carbon on the end. It's going to get a second H on the end. So H is on either side. It has one carbon in it, and its ending is al. What do you think that is called? One carbon in it, and its ending is al. Isaac, what do you think? Methanal, right? Different than methanol, it's methanal. Methanal. There's an old name that goes with that. That is also known as formaldehyde. All right, and so you may have heard of formaldehyde before. Does anybody know what formaldehyde is used as? It's used to preserve tissues and animals and that. So let's say you dissect, a pig or a frog in science class. There's a small amount of formaldehyde in that preserves it, keeps it from going bad. All right. They used to use pure formaldehyde, but it's been determined that formaldehyde is a carcinogen. It is cancer-causing. So they've determined they can put a very small amount in with water and some other chemicals, and it's safe, but it still does the job. All right. So this is also a low boiling point, but it tends to be a liquid at room temperature. Okay? So notice how I'm progressing. Oxygens with two single bonds. Now I've got an oxygen with a double bond. In the aldehyde, it has the double bond, and it's connected in the end to an H, just like I connected the alcohol to the end with an H. Now I'm going to put the carbon with the double bond in between two carbons. And with that in between two carbons, it becomes a ketone. And I really don't know the origins of these words. There's a lot of words I do look up the origins for. I don't look up these. I don't know what, because I just don't care that much. I should maybe sometime. So that's a ketone. And its ending is -one. And the first one I can have must have 3 carbons in it, because I need to have 2 carbons on either side. Sorry, that's a CH3. The ending is -one. I must have 3 carbons. So what do you think this is called? Stephanie's looking, she's thinking, she's looking at the number 3. What do you think? Give it a shot. Propone? Yeah. We call it propane, so we go propanone. We keep the AN. Propanone. 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 And propanone, also low and also liquid. And ketones, I really don't know any specific uses. Nothing that I've looked up. You'll be able to find something. I think there's a biological process that produces ketones in the body. I heard some biology students talking about it. I really don't know. You might find some information on that. Okay. We are getting there, a few more. So I've done oxygen, 2 single bonds, one on the end, one in the middle. I've done oxygen with a double bond on a carbon, one on the end, one in the middle. Now we're going to add 2 oxygens. We're going to have an R with a carbon and the double bond, just like we did. But now we're going to have an O and an H off the end of that. What I'm doing as we go along is I'm increasing the contact with oxygen and carbon. The first one I did, the alcohol, and I'm just going to go back, show you what I'm looking at. The first one I did, notice there was 1 bond between oxygen and hydrogen. The second one I did, there were 2 bonds between, there was 1 bond between oxygen and carbon. All right. Here there's 2 bonds attached to carbons. Again, also 2 bonds attached to carbons. 2 bonds attached to carbons. Now, you'll notice with this one, I have 3 bonds attached to this carbon. So we have more oxygen to carbon contact. Okay? That's how we're setting it up. This is called a carbox, and I better get the spelling right, carboxylic. Does it have a Y? Oh no, I'm going to spell it wrong. Carboxylic acid. Esters. I want to get the spelling right. Oh, it does have a Y right there. Carboxylic acid. Excellent. Carboxylic acid. Nice. And it is an acid. We've actually encountered one of them already. I will draw the one that we've already encountered. Its end is blank-ic acid. Just like our other acids. Something-ic acid, depending on how many carbons it has. The example I'm going to give, CH3, CH3, C double bond O, and that's a mistake, OH. CH3, COOH. And I don't know what I was thinking where I put that extra line up and down. Ignore that. I can't erase it. We okay with that, without that funny line? This line here, I apologize. It's C single bond, CH3 single bond C, O, OH. That line there is a mistake. That up line. This is called ethanoic acid. Ethanoic acid. It's got 2 carbons, and then it's got that acid group. This is also known as acetic acid, which we know is as vinegar. All right, so that's the other way of naming acetic acid. It's ethanoic acid. The boiling point compared to the other guys is high. At room temperature, it can be found as liquid, but sometimes can be found as solid. Ethanoic acid in its pure form is sometimes called glacial acetic acid because at room temperature, it sometimes has crystals in it, like a glacier forming, because it's right in between being a liquid and a solid. Okay, and one more, and then I want to go back and look at some others. I started my list at the wrong time. So one more, and it's called an ester. And again, notice I have an H here, just like I've been doing. As I move down, I've been swapping out the H for R groups, for more carbons on the back end. Now, the name for this is also very complicated. because the name comes from the two things that we put it together with. And actually, I'm going to teach you how to make esters. And we actually get an ester by reacting an alcohol with the carboxylic acid. We put those two together and we get them to stick together in a certain way. And their name comes from the alcohol that we use and the carboxylic acid that we use. What we've made it from is going to generate the name. An example of an ester, I'll do CH3, C double bond O, O, and then a CH3. So I'll put a CH3 on the end of it. In making this particular ester, I would have had to start with methanol, and I'll show you the reaction in a moment. And I would have needed to use the carboxylic acid ethanoic acid. So the name comes from those two chemicals that we use to make it. This is called methyl, and it's supposed to be one word, but I'm going to run out of room. Methyl ethanoate. What a great name. We put an 8 on the end of it. Methyl ethanoate. You are not responsible for knowing how to name those. But that's just fun to say sometimes. Methyl ethanoate. And esters, you might think because they're even larger, would be also solids, but they're not quite as high as the acids. So I'm going to put here liquid. They're high, but they tend to be liquids at room temperature. Okay? Now, those are the ones with oxygen that I want you to know, but because I'm letting you have this on your test, right? So you're going to write it very neatly, not anything else, because I'm letting you use that on the test. I'm going to add 2 more functional groups that we already know. So if I were to write down here C double bond C with the chance of having some R groups on the end. Does anybody remember what we call it when we have a double bond? What do we call that group? A little bit of review from last week. Sorry, say that again. Alkalines. That's fun. They actually used to be called alkalines in the past. They had the alkyl on it. But they've changed the naming system where they got rid of the alkyl and they just call them alkenes, right? Remember alkenes? But alkaline would be a correct statement. That would be using terms that we have used in the past. But I'm just going to write alkene. Alkene. And again, there's the ene. We put the ene on the end of it, right? And if I write the simplest one, CH2, double bond CH2, what's that called? And here you're going to have to know how to name those. What's that? Ethylene, that's an old name. That would be correct again. They used to call it ethylene, but we don't call it that anymore. Ethene, ethene, ethene. What's that? I don't know why you're sticking the YL in it. It's an old naming system. It is valid. It's an old naming system. But we're now going with ethene. We got rid of the YL. Ethene. Don't forget, if we've got something greater than 4 carbons, you need to put a number, right? You either have one butene or 2 butene. Okay. These guys, these are very low boiling points. They are gases at room temperature. And the other functional group we've learned, C, triple bond C. Again, I'm putting R groups on it. It could be H's, but I'm putting R groups there. And what are these called? Yeah, don't get sucked into, alkyne is correct. Alkynes, or alkyne, good. ending Y and E. I'm going to just put the simplest one, a CH with a triple bond and then a CH. And that is ethine, and again, low and gas. All right? Okay? So there is a summary of the different ways in which oxygen can bond to organic compounds. And really, that's just to give you an idea of the complexity in which organic chemicals exist. There is a sheet, a practice sheet on the Google Classroom, which just has some chemicals on it, and I ask you to locate, and you could go ahead and circle and name the different types of groups that we've maybe learned. So if someone could point out to me a group that looks familiar to you, use your sheet if you've got it nearby. Anybody see some connections that we just wrote down? Anybody see some connections that we've got here? Yep.
The CH, very last one.
Over here,
The
the CH, the CO, and the O, and the CH3. So this group right there, I agree. What was that called? Yeah, that's an ester. That's an ester. So what are you looking at with your eyes? You're looking at the C double bond O and the O. If you had circled it like this, I would have said as well, good, you've circled it. And this is an ester linkage. It's an ester. Does anybody see any others? Yep.
The very first, like, three.
Right here at this end? Yep. And what is that? Is correct. All you got to do is say it. Carboxylic acid. That is a carboxylic acid. Carboxylic acid. Excellent. You might think that that's a ketone, but it's not. Why is it not a ketone? It's an N. It's not a carbon. That's a different thing. Okay? This actually is what we would call an amide, but I didn't teach you about the ones that have nitrogen in it because I thought I'd taught you enough for one day. Okay? So and by the way, this is aspartame, which is the artificial sweetener. So that's what that molecule looks like. If you take Diet Coke, right, lots of aspartame in that, or those those artificial sweeteners, if they have aspartame in it, that's the molecule right there. Okay? All right. So on that sheet, there's just a bunch of different compounds you're asked to circle and practice. And on the test, I have a couple of them where you'll just circle and practice. That's how I'm going to test you on this. But you'll get the sheet because I'm not going to have you memorize all those things. Okay? All right. Now for the last part of today's lesson. Oh, I do have another example. Oh, let's do one more example. Let's see if we can find some others. Let's find a couple more here. Again, if you didn't write it down, it's not a big deal. Anybody see any that stand out to you? And again, all of them, it doesn't have to necessarily be just with oxygen. Any functional groups that you see that we've encountered. Come on, Shay, there's got to be something you're picking out there. What? Something looks familiar to you. Oh, come on, there's all kinds of them. All right, I'll help you out. Shay, what would that be called? You've got a page right in front of you that has all the answers. Oh, I don't need the name of it. I just want the name of the family or the functional group. So tell me the name of the family it's in. Yeah, that's an alkene. Alkene. How about that one right there? What's that? Felicia, what's that? Look on your sheet. It's on your sheet. You're looking for an OH bonded to a carbon. She wasn't listening. It's perfect. Right at the top of the page. It's an alcohol. 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 What about this one right here? I have no idea. C double bond O with an O, and then each end is bonded to C's. C double bond O with an O, and then each end is bonded to C's. Yep. Yeah, that's an ester. An ester linkage right there. Ester. Again, you're looking for that C double bond O with an O, and then the fact that there's two C's. Not the entire test, but a question on the test is going to be like this.
It's going to be all like confusing like that?
Yeah, it's going to be confusing like that. You're going to have to pick it out. Yep.
Will it tell you like how many to go? You just go average?
No, I would likely give you a certain number of marks and say maybe pick out 3 or something like that. Yep.
So we're done with this one.
No, actually, I could pick out another one. Look at this O here is bonded to 2 carbons in that way. That O is in the middle, bonded to 2 carbons. That's an ether, correct. Yep, ether. Good. And there's another ether link there. That's an alcohol again off of that one. I think we've got them all at this point. I think we've got them all. Okay? All right? Okay. That's ascorbic acid. That is, ascorbic acid is vitamin C. That's vitamin C. Okay. So let's talk about how we make esters. And the reason for that is because, well, it's just kind of fun. Esters tend to be, I don't even know how to describe it. They have odor to them. There are many odor chemicals that are esters. And esters are formed naturally. So when you take that, let's say we're talking about a lemon, and we're not talking about the lemon juice that's in the middle, but you know how if you squeeze the lemon rind or the lemon peel, you get that smell of lemon that's on your hand? That is an ester, okay? So there are many natural esters that give various things odors, but we can synthetically make esters, and that's what we're going to do in our lab on Wednesday. We're going to react a carboxylic acid with an alcohol to make an ester. Yep. Yes, correct. Yep. Yeah, so, you know, you could even take, you know, your organic chemistry and go into that industry, right? You could even create various types of esters and, you know, be a perfumist.
Just go.
Okay. Esterification is a reaction between an alcohol and a carboxylic acid to form an ester. Now, the name for a reaction, an organic chemical reaction, that takes 2 smaller molecules and joins them into a larger molecule is called a condensation reaction. Now, I know that condensation often deals with water vapor condensing, say on a window or on a mirror, but that's not why it's called that. When 2 small molecules join to make a big molecule, the bigger molecule tends to be a liquid. And so when you put your small molecules together, it tends to form a liquid substance. It appears to condense. Another way of thinking of the term, we're taking 2 substances and we're putting them together in one. We're condensing it down. We're making it come together. In order for this reaction to happen, we need a catalyst. We haven't discussed catalysts much in this course. Does anybody know what a catalyst does? Anybody know what a catalyst does?
There's something in biology.
Yep, you would have talked about it in biology. What's it do? It speeds up a chemical reaction. In this case, the catalyst sulfuric acid is hydrophilic. Hydro means water, and the suffix philic means to love, right? Water loving. So hydrophilic means that the sulfuric acid rips a water molecule off of those other molecules and sticks them together. And the reason I'm teaching you this is so that we can do the lab and make esters, because it's fun. It's a fun lab. What's that? It stinks like awesomeness. I had a student in the end once, when we put all the waste into one container and it was all these esters, she said it smelled like rainbows. And it does. I didn't hear that, so I'm going to continue. Can I continue? Yeah, but it smelled like rainbows? Okay, here's an example of, I didn't give any names. I can't even remember that student's name. Terrible. Okay, so here is an example of a reaction that you will have to do on the test. What will you have to do? I will give you the reactant. I will tell you that it's going to form the ester, and you're going to have to know how to do this, right? So you're going to have that picture. So here's what happens. We put in the H2SO4. Now, it's a catalyst, so we write it above the arrow. It doesn't actually get used up in the reaction. It's just there to help it along. What does it do? H2SO4 loves water, so it's going to rip two H's and an O off of these molecules. Now, you'll notice both of them have OH on the end. And don't worry about which one it actually rips off. It doesn't make any difference. So I'm going to take a different color, and I'm going to say it's going to rip off an H from that one and an OH from that one. See how I circled an OH on one of them and an H on the other? And you know what, folks? To be honest, I don't know which one it really rips off. You know what I mean? From which molecule it actually takes the O from, and I don't care. The most important part, though, is now that this carbon is going to link to that oxygen. It forms a link as the water is removed. So in the end, your products will be water. And now, draw what you have left from left to right, connecting the oxygen to the carbon. So, starting out there, CH3. It doesn't matter that the H is on the other side. That's just the way my computer program does it. It doesn't have to be on an angle, but again, you can do it that way. C double bond O. Working my way this way. O. This H and this OH have been removed, so the next connection is carbon. Doesn't matter whether you go up or down, I really don't care. CH2 and the end CH3. Okay? I'm going to expect you to be able to do that. I'm not going to expect you to name them, but just telling you, this was ethanol. This was ethanoic acid. So it's named ethyl ethanoate. You don't have to worry about that. The acid, look at it says here, the acid loses the OH and the alcohol loses the H. You can write that down that way. I have it drawn differently. I don't care how you draw it. If you just see it and you take an H off of one, the O, it doesn't make any difference. You're going to end up with the same connection in the end. So I don't care how you draw it. I've drawn it the other way. I don't care how you draw it. I don't even care how you write it. You could have said that the acid loses the H and the alcohol loses the OH. I don't care. There is one way that is correct. I could check that big blue book there. I really don't care that much. It results in the same product. And then the remaining parts join together. Because there's two molecules becoming one bigger one, it's called a condensation reaction. So let's do, I think I've got one more example, and then I think I'm done. Two more examples? Oh. We might be able to get the point across with one. Let's do the one on the bottom then, because it's more complicated. You already started drawing the top one, didn't you? The bottom one's difficult to draw. I want you to draw it. Because we're going to be doing, in our lab, we're going to be involving one that looks complicated like this. It has this ring structure in it. So we might as well practice it. So this ring structure has carbon, 6 carbons in a ring in a hexagon. Each carbon has one hydrogen bonded to it except this guy that has the acid group connected to it. See here, see our carboxylic acid group, C double bond O, OH. Yep.
So in every example, will there be an obvious, like, two OHs to,
Yes.
like,
Yep.
the obvious?
Yes, because there has to be the carboxylic acid group, which has an OH on it, and there has to be the alcohol group. So if I'm expecting you to do this, I have to give you those two types of chemicals. If I gave you something different, it would not be an esterification reaction. It would be a different. And I wouldn't do that because you haven't learned about that. And the way you do these types of things, you memorize them. You memorize which two types there are. See, in the 12U and in university, they throw all kinds of different reactants at you. You had to memorize those many hundreds of different reactions, and you've got to be able to say, oh, this is the reaction that takes place. And I was not very good at it. So I did other things. Then I did mathematical chemistry instead of this. Okay, so let's do the bottom one. Again, I don't care. It said take the OH off of the acid and the H off of that. It doesn't matter because you're still going to have this carbon connected to an O. Get you the same thing. Again, H2SO4 is the catalyst. We're going to have water, and I'm going to start drawing down here because this is obviously large. So I'm going to need my hexagon. 1, 2, 3, 4, 5, 6. That connected together. And I got a double bond there, there, and there. And this goes out to there. O. This now goes to the O. And now I've got my 3 carbons on the end, and I'm going to be in trouble for space. CH2, CH2, CH3. I tried to do a zigzag, but I ran out of the end. And I need to add my extra H's on these guys. H, 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 H. All right? This is called benzoic acid, and this would be called propyl benzoate. Propyl benzoate. Yep.
And these are like, whatever they're called, but the reactions
They're-
always be balanced, right?
Yes, because it's 1 and 1, producing 1 water and 1 ester. Yep, it's just literally sticking them together. Okay? So those are esterification reactions. And that's where I'm done. And now I'm done the organic unit. Tomorrow, like I said, I'm away, so you're gonna review. Then on Thursday, we're gonna do the esterification lab. We're gonna make some esters. We're gonna make 3 esters, and then we're done. What's that? Wednesday. And then the test is on Thursday. Okay? Let me stop the recording here for a moment, and then I'll tell you one more thing about the lab.